and I'm going to start with the Trojan concepts, okay? So what is a Trojan? It's a program in which the malicious or harmful code is contained inside apparently harmless programming or data in such a way that it can get control and cause damage, such as ruining the file allocation table on your hard disk. So Trojan is pretty much very well known, and is a malicious malware which essentially destroys your functionality, okay, the functionality of your system. It can damage all the files, it can damage the allocation table on your hard disk, it can damage the network activities that are being carried out, and obviously it can then create a channel between the hacker and your system where he can transfer the sensitive data from, okay? So how do they use Trojan? They delete or replace operating system critical files. They can generate fake traffic to create denial of service attacks. They can record screenshots, audio, and video of victims' PC. They can use victims' PC for spamming and blasting email messages. They can steal personal information such as passwords, security codes, credit card information, etc. They can also encrypt the data and lock out the victim, and they can ask for money. All right, so can also help with the ransomware as well. How to infect systems using a Trojan? You can create a Trojan using the Trojan Horse Construction Kit. It's pretty much available online. You can look over it over the internet and can download it. And once you get hold of this, then you need to first create a dropper, okay? A dropper is something that can help you define a packet, okay? A Trojanized packet that can install code onto a target system. You will then install a wrapper around it, and then you can propagate the Trojan onto the victim's computer. Example of a dropper installation path, SVC host. So these are all examples of a dropper. Trojan horse construction kit. So the Trojan horse construction kits help attackers to construct Trojan horses of their own choice. The tools in these kits can be dangerous and can backfire if not executed properly, okay? So you can use all these Trojan horse construction kits. We have been over this topic before as well. So I'm just going to speed it through, okay? Trojan horse construction kits include Trojan horse construction kits and a spy Trojan generator, batch Trojan generator, Umbra loader, botnet Trojan marker. All right, so Dark Horse Trojan virus maker is one of the virus makers. You can use this to create a Trojan. All right, so on to wrappers. Our wrapper binds a Trojan executable with genuine-looking exe applications, such as games or Office applications, yeah? So when a user runs the wrapped.exe file, it will install the Trojan, and once the Trojan is installed, it would keep running in the background, okay? So the attacker might send a birthday greeting that will install the Trojan, so anything that the attacker might want to get the attention of the victim against, he can use that to install a Trojan, okay? So the wrappers use our Elite Wrap, Advanced File Joiner, Soprano 3, and iExpress Wizard include self-extracting packages that can automatically install the embedded set of files. Crypter is a software which is used by hackers to hide viruses, keyloggers, or tools in any kind of file so that they do not easily get detected by antivirus. Okay, so we have been talking about cryptors quite a while. So you can use cryptors to hide viruses and keyloggers, and no antivirus would be able to detect them. Okay, so you can use Java cryptor. That's one of the best, and hidden site cryptors. These are my two favorite ones. Of course, there are other tools as well. Bitcryptor can be used to encrypt and compress a 32-bit executable without affecting the functionality. Now, how do the attackers deploy the Trojan? Yeah, so what the attacker does is that he sends an email to victim containing the link to the Trojan server. Yeah, so when the victim clicks the link, it immediately installs and connects to the Trojan server in wherever it is. It goes over the internet to the Trojan server, and then that Trojan is sent to the victim. Okay, so sometimes if you do not send a exe file containing the Trojan, you can always send a link to the victim. Yeah, on who's so when the victim clicks on that link, it can always connect to the server and download that file. Okay. Exploit kits can be used. This can be used to obviously target the system. Where, for example, when a victim visits a legitimate website, the legitimate website sometimes can be hosted onto a comprised web server. So victim is actually redirected through various other servers, and the victim unknowingly lands on the exploit server. Yeah, I can hear you. All right, so can you please mute all yourselves, guys, just to avoid background noises, just in case if you're at a busy place, okay? Thanks a lot, guys. All right, so when it happens, then the exploit kit can gather all that information on the victim's computer and then deliver the exploit. Brick EK is one of the exploit kits. It's pretty well known by attackers, but Angler is one that is pretty famous out there. Okay, so Angler is one kit that can be used, and then this can be used to exploit the victim's computer. Okay, against ransomware as well as all kinds of Trojans. Evading antivirus techniques: break the Trojan file into multiple pieces and zip them up as a single file. So if you want, if an attacker wants to evade the antivirus, as I told you guys yesterday, Kaspersky is one of my favorite antivirus. It's pretty good in detecting these Trojan files. So if you want to evade the Kaspersky antivirus, what you would be doing is that you would break the Trojan file into multiple pieces, and then you would zip them up as a single file. Okay, and again, it's a good practice to generate and write a new Trojan rather than get your hands on one. Okay, and then you can obviously change the syntax of those Trojan files, okay, those executables, so that it's not easily detectable. It's just like if you change the name of an image from, which is a JPEG, you can always add an extension of .bmp against it, okay? So change the content of the Trojan using hex editor and also change the checksum and encrypt the file. Never use Trojan downloaded from the web. As I said, don't do that. Create your own. So types of Trojans: remote access Trojans, backdoor Trojans, botnet, rootkit, e-banking, mobile proxy server, covert channel, defacement, IoT, security software disabler. So these are all kinds of Trojans. Remote access Trojans. This Trojan works like a remote desktop access. Hack against complete graphical user interface access to the remote system. For example, Jason is our attacker sitting in one of the bad places, and he can gain 100% access to one of you guys who gets infected with the red Trojan. Okay, so red Trojan is a Trojan, it's a remote access Trojan that gives full remote access to the attacker. It uses port number 80, and it is pretty much out there, guys, and you need to be very careful with it. Backdoor Trojans. A backdoor Trojan can bypass the security's mechanism to gain access to a restricted area of a computer system. Backdoors are used by the attacker to have uninterrupted access to the target machine. Backdoor Trojans include Snake, very famous, and Nitol. Okay, so it's also known as Nitol. It depends on how you pronounce it. Poison Ivy is also a Trojan, backdoor Trojan. tool that can give the attacker complete control over the infected computer. So how it works, it actually copies itself to the Windows folder, and then it bypasses the security mechanisms to give complete access to the attacker. Botnet Trojans infect a large number of computers across a large geographical area to complete a network of bots that is controlled through a command and control center. This is essentially done on large scale, and you can guess many bad advanced persistent threat happening and taking place using these particular Trojans. Okay. So Plugbots, Windigo, and Crydex are three well-known. Others are Proteus malware, Andromeda bot. Haven't heard of it before, but it's something new for me as well. But this seems like one of the new ones. Might want to check it out. Avalanche is pretty well-known. Crydex, Dreambot. So these are all botnet Trojans. Rootkit Trojans. Rootkits are considered as powerful backdoors that can specifically attack the root of the operating system. It cannot be detected, guys, so you have to be very careful about that. And Finfisher, Greyfish, Whistler are the famous ones, okay? E-banking Trojans, we all use e-banking, yes. We don't want to be victim of an attack. You don't want an attacker to get your account information, okay? So what e-banking Trojan does is that it intercepts the account information before it is encrypted and sends it to the attacker's Trojan command and control center. It's pretty bad. So what happens is that the attacker can upload any advertisement over the internet, okay? And also, attacker obviously has been working on the command and control center, where he would be evaluating and analyzing all these roles and all these processes that he's going to be working with. And then he publishes these advertisements on legitimate websites. So how does he do that? It's very easy for him to do that because the user accesses a legitimate website and can click on the malicious ad. Yeah. So once she can do that, then the victim is directed to the malware server. Okay, the malware server, which is established by the attacker. Yeah. So the malware server then provides the Trojan to the user's computer where it gets installed, and then the user can fall a victim to that, since the Trojan is going to be reporting that particular machine as a new bot. So the attacker is going to gain control over it, and the attacker is then going to instruct the Trojan to track the victim's access to any bank account. Okay, so the user sometimes wants to log into her bank account. The Trojan is going to report the victim's activities back to the command and control server, and that's how she's going to fall victim to it, okay? And once the details are with the attacker, obviously he can do and manipulate the transfer values. The working of e-banking Trojans. So how many of you work with e-banking? Every one of us now does that,
Yes,
right?
we all do.
Yeah. So everyone does that. So we have to be very careful. We need to be aware of these Trojans: the TAN grabber, HTML injection, covert credential grabber, form grabber. They're all some of them. Okay, so they all intercept transaction numbers. They create fake form fields on e-banking websites after the legitimate websites form victim to the attacker, or maybe if the attacker somehow can use phishing and cause you to access a website which is not authentic but appears to be legitimate, and then make you enter all your credentials there and copy them, okay? So the form grabber is also a Trojan analysis post request and response tool that targets the victim's browser. It compromises the authentication and intercepts the input. E-banking Trojan, Zeus. So have you heard of Zeus? It's pretty common. It's pretty well known. It's pretty common because it's very famous. Okay, so Zeus, the Z-bot, is an e-banking Trojan that steals data such as online credentials, banking details from infected computers via web browsers and protected storage. The e-banking Trojans that can be used for this purpose include GoodKit, Sniffler, Dinbar, so there are a lot there. Proxy server Trojans. Trojan proxy is usually a standalone application that allows remote attackers to use the victim's computer as a proxy to connect to the internet. Proxy server Trojans, when infected, starts a hidden proxy server on the victim's computer. Thousands of machines on the internet are infected with proxy server using this technique. Proxy server Trojans include proxy, pink slip bot, and Linux. Okay. Covert channel Trojans presents various exploitation techniques, creating arbitrary data transfer channels in the data stream authorized by network access control system. So that's how you can use this, because it's a covert channel channeling tool, which is not gonna expose the Trojan. All right. So a client interacting with a covert channel channeling tool, a client would be accessing a firewall through which packets traffic would be transferred using HTTP proxy chain over the proxy chain to these covert channel channeling tool server, and obviously to the target services. That's how it's done. It enables the attackers to get an external server shell from within the internal network. It sets a TCP channel, allowing the TCP data stream between external server and the box from within the internal network. The defacement Trojan. Resource editors allow a user to view, edit, extract, and replace strings. They allow you to view and edit almost any aspects of a compiled window program. They apply user-style custom application to deface window application. Service protocol Trojans. These Trojans can take advantage of vulnerable service protocols like VNC. A VNC Trojan starts a VNC server daemon in the infected system. For example, if an attacker uses its command and control to send an instruction to a victim's computer to connect to a VNC server, the VNC server is gonna get infected with that victim. Is going to get infected with that VNC Trojan, okay? So that's where the attacker can connect to the victim using the VNC viewer, and this Trojan will be very difficult to detect using any antivirus. Then there are other Trojans, service protocol Trojans, that include HTTP and HTTPS Trojans, which can bypass firewall and work in a reverse way of a straight HTTP channel, because when a victim is trying to access a server using the HTTP request to download a file, the server would rather be responding with a Trojan passing through that HTTP reply, okay? So that's how this works. Mobile Trojan attacks are increasing rapidly due to the increase of mobile usage globally. Hammer is one very well known by attackers, famous. It's really hard to detect. It's pretty good. So Hammer is a Trojan that runs on Android operating systems. When the device is infected, the Trojan is gonna root the phone to gain admin privileges, and then it will pop up different ads on your phone. So you're gonna get some really nasty treatment. IoT Trojans, Internet of Things is the thing nowadays. All of the electronics are now connected with the internet, your buildings, your refrigerator, your television. So all are connected to the internet. And the IoT Trojans specifically target these devices, okay? They attack these networks, they attack these devices, and they use multiple tools, multiple Trojans for this purpose. The attackers, they can use Mirai, they can use Trojan.linux.pnscan, and BrickerBot. Trojan corrupts the IoT device storage capability, all right, and reconfigures the kernel. All right, moving forward, virus and worm concepts. Introduction to viruses. A virus is a self-replicating program that produces its own copy by attaching itself to another program. Stages of a virus: design, replication, launch, detection, incorporation. Execute the damage routine, okay? All right, so design, developing virus code using programming language or construction kits. Virus replicates itself for a period of time with the target system. Then it gets activated with the user performing certain actions. And then the virus is identified as a threat infecting targeting system. Working of viruses: infection phase and attack phase. Two very well versed phases where they work, and sometimes it's really hard to detect a virus if it's really nasty, okay? So in the infection phase, the virus replicates itself and attaches to an exe file in the system. So before infection, the file header is a clean file is actually added with the virus. Yeah, so it attaches to the .exe file of the system. So once this file is infected, then it starts with the attack phase. Viruses are programmed with trigger events to activate and corrupt systems. Some viruses infect each time they are run, and other infect only when a certain predefined condition is met, such as a user-specific task, a date, time, or a particular event. So first, infection phase, it attaches to a .exe file, and then it triggers, okay, and it infects and corrupts the systems. Indications of virus attack: processor take more time, more resources, computer beeps with no display, so drive label changes, and we have all been through this, yeah? We all have got our PCs infected one or more times years back, yeah? When we were not aware of these things. So then computer freezes frequently, files and folders are missing, suspicious hard drive activity, browser window freezes, lack of storage space. You are trying to find spaces and you don't have any, okay? And you are wondering that you had so much space initially, and now your hard drive seems to be full. Unwanted advertisements and pop-up windows. So that's all an indication of virus. Abnormal activities: if the system acts in an unprecedented manner, that is categorized as abnormal activity. False positive: not all glitches can be attributed to virus attacks. For example, if you guys are on Twitter, so when you log on to Twitter, you can see all Twitter feeds popping up on the right bottom of your screen. Yes, so initially when I was new to Twitter, I was having a false positive. I got worried, yeah, but it's all good if you have a good antivirus and you are just going to Twitter and nowhere else. Okay, how does a computer get infected by viruses? When a user accepts files and downloads without checking properly for the sources. That's how you can open, in fact, the email attachments. I've been talking a lot about this one aspect. Installing pirated softwares, not updating and not installing new versions of plugins, not running the latest antivirus applications, clicking malicious online ads, connecting to untrusted networks, okay? Virus hoaxes. Hoaxes are false alarms claiming reports about non-existing viruses which may contain virus attachments. So you might want to be careful about this. Your system might display some pop-ups, some screens, which is asking you to do some stuff, but it's not really a virus, okay? Trojan.down blocker, ransom.defrag, Sonar MS Office G23, these are type of virus hoaxes. So there's one example here of Zeus Friday scam, which is famous in 2017. So that's the alert people had on their systems. Fake antiviruses, ScanGuard, Antivirus Gen, TotalAV, they are all fakes. If you find them over internet, don't download them, okay? They look authentic, but when they are installed in your system, they damage your system, okay? Antivirus Pro 2017. It's all fake. Ransomware is a type of malware which restricts access to your computer system files and folders and demands ransom payment to the malware creator in order to remove the restrictions. Locky is one of the ransomware that infects the system and corrupts data, okay? So here's a list. CryptoVault ransomware, Crypto Defense ransomware, a whole list of ransomwares, okay? Types of viruses, file virus, macro, cluster, companion, metamorphic, terminate, direct actions. You might want to just Google them out. Don't download them. Please don't download these files. Just Google what these are about, okay? Module flow. All right, so malware analysis, yeah? So ship dipping refers to the analysis of suspect files, incoming messages for malware. So when you hear the term ship dip computer, you're referring to analysis of suspecting files, okay? So what you do is first you run the user group permission and process monitors, then you run the port and network monitors, and run device drivers and file monitors, and then run the register and kernel monitors. Antivirus sensor systems. An antivirus sensor system is a collection of computer software that detects and analyzes malicious code threats, such as viruses, worms, and Trojans. They are used along with sheep-dip computers. Guys, can you please start your labs? I'm going to just grab some water real quick, and we can then continue with the lecture first and the labs. Meanwhile, can you please just log into your labs, and I'm going to tell you what lab to log in, okay? Antivirus sensor systems. An antivirus sensor system is a collection of computer software that detects and analyzes malicious code threats. It's pretty good because if there are systems on a network, then these antivirus sensor systems can help you determine all kinds of malicious code threats, okay? Introduction to malware analysis is really done using the reverse engineering technique, and you use a piece of malware in order to determine the origin, the functionality, and essentially the impact of the given malware. Why do we use malware analysis? To determine exactly what happened, to determine the malicious intent of malware software, to identify indicators of compromise, to determine the complexity level of intruder, to identify the exploited vulnerability, to identify the extent of damage caused from the intrusion, and to catch the perpetrator accountable for installing the malware. There are two types of analysis: static malware analysis and dynamic malware analysis. So the static analysis is used for code analysis, because that's where you go through all those binary codes without actually executing it and having a better understanding of how the malware works and what's the purpose. The dynamic malware analysis goes over the behavior analysis, and it involves executing the code to know its interaction with the host system and the impact of the system. Malware analysis procedure. Preparing the test bed, you allocate a physical system for the analysis lab. Please do not attempt it on your system. You need to create a lab, okay? So if you have just one system, maybe just go for virtual machines, but do not do it on your physical machine, okay? So you need to have a separate physical system for the analysis lab. That's the best approach. Then you install virtual machines over it, install guest OS, operating system, isolate the system from the network by ensuring that the card is in host-only mode. Okay, you don't want to be transmitting the traffic to your system as well. You need to simulate internet services using tools such as INetSim, disable the shared folder, and the guest isolation. Install malware analysis tools, generate hash value of each OS and tool, copy the malware of the guest OS. Okay. So we talked about the static malware analysis. In static analysis, as I said, you're not running the code, you're going over it. So some of the static malware analysis techniques include file fingerprinting, local and online malware scanning, performing string search, identifying file dependencies, malware disassembly. So these are the techniques. Starting with file fingerprinting, it's a process of computing the hash value for a given binary code. You can use the computed hash value to uniquely identify the malware or periodically verify if any changes are made. Okay, so the tools you can use include HashTab, HashCalc, MD5 Deep, MD5 Sums. They're all brilliant. Static malware analysis, local and online malware scanning. Scan the binary code locally using well-known and up-to-date antivirus. Tools include Joti, MetaDefender, Online Virus Scanner, Threat Experience. Virus Total is a free service, okay? So sometimes it's not always good to use these kind of tools, but the local and online malware scanning tools, Joti, MetaDefender might provide you with some response and reports, okay? Performing string search is another approach. Strings communicate information from the program to its user, analyze the embedded strings of the readable text within the program's executable file. Bin text is a text extractor that can extract text from any kind of file and include the ability to find plain text. So in order to perform string search, bin text is the right approach, okay? So other string searching tools include flaws and strings itself. Identifying packing of obfuscation methods. PEID tool, PEAT, is a tool that provides details about Windows executable files. It can identify signatures, so it's a really, really good tool, okay? It can help you with identifying the packaging of the malware. Then there is finding the portable executable information. You can use tools like PE Explorer for that purpose, because these tools can help you analyze the metadata. Metadata stands for data about the data, so metadata of that file, and it helps you get information such as time and date of compilation. Other tools include Portable Executable Scanner, Resource Hacker, and PEView. Static malware analysis, identifying file dependencies. You can use Dependency Walker, which lists all the dependent modules of an executable file and builds tree diagrams. It can record all the functions of each module, export and calls. These tools include Dependency Check, Hakiri, Retai.js. Dynamic malware analysis is pretty much the thing to do for newbies, because the static malware analysis involves some good skills. So in this, the malware will be executed on a system to understand its behavior after infection. This type of analysis requires safe environments such as virtual machines and sandboxes. Dynamic analysis consists of two stages: system baseline and host integrity monitoring. System baseline refers to taking a snapshot of the system at the time the malware analysis begins, and host integrity monitoring involves taking a snapshot of system state using the same tool before and after the analysis to detect changes. Port monitoring, installation monitoring, file and folder monitoring, these are all monitoring that we do, including, it also includes, and also registry monitoring, and apart from that, API calls monitoring. Port monitoring, you can monitor the ports. You can use NetStat, TCP view. We have been using some of these tools to scan for suspicious ports and look for any connection establishment to unknown or suspicious IP addresses. Dynamic malware analysis process includes process monitoring. Malware camouflage themselves as genuine Windows services or hide their processes to avoid detection. Please use process monitor for this purpose because it's going to give you real-time file system registry activities, okay? You can use tools like Process Explorer, Monet, System Explorer, Security Tasks, Manager, and ESAT, Sys Inspector. That's great. So finally, we are loading the VM. Just quickly load into the VM the Parrot Security CEH v11 Parrot security machine, please. And let's continue, okay? Right. Just log into the Parrot security machine and we can continue, yeah? Right. So once you log into it, can you please write the command sudo space su, and it's going to ask you the password. You can write the password TOOR and press enter. Right. Send the command cd. Good. Now can you please do the nmap scan over it? And we're going to write the command nmap space -p space 21.10.10.1.10. Okay, so nmap space -p space 21, which is the port number, space 10.10.1.10.
Nmap.
Yeah. Okay, so what we are trying to do is that do the nmap scan over port number 21. So for that, you need to write nmap space -p, which stands for port space 21 space, now the target machine IP address, which is 10.10.1.10. 10.10.1.10. Press enter. Okay, so this command is going to reveal the open port, which is 21, and it's the service is the file transfer protocol, the FTP. So that's great. So now we need to be performing this sign packet flooding on the target machine. Remember the sign packet, the synchronization packet that I taught you guys during the OSI module, the TCP IP handshake. So we are going to be doing the sign flooding, okay, on the target machine using the port 21. So can you please type msf console from the command line? This is just gonna launch Metasploit. And we are gonna use the sign flood module to do that, okay? Press enter, yeah. Right. So once it's launched, then we are going to be using the auxiliary sign flood, okay? So can you please write auxiliary, AUXILIARY? AUXILIARY slash DOS, denial of service, LIARY. AUXILIARY slash DOS slash TCP, the protocol. Can you please, TCP slash sign flood, yeah? So we're gonna be doing the sign flooding here. Sign flood, great. and press enter. Okay, it says because you did not use the word use before auxiliary, yeah? So can you type USE, use, space, and type the above command. Oh no, it's not typing perfectly fine. There are problems. Okay, let me tell you what to do. Can you please press the above arrow button? Yeah, and can you go back, use the left button, and just enter use and press spacebar, okay? Type use, USE, space, press enter. Okay, it says no results from search. And that's probably because of the spelling mistake. The auxiliary contains only one L. Okay, so press the above arrow button again, go back and remove one L from auxiliary, okay? Press enter. Here we go, okay. Oh, you did not write DOS. It's a denial of service. It's not document. Slash DOCS. No, it's slash DOS. We want to be performing the denial of service attack, right? So using the sign flooding. Just remove the C and remove one L again from auxiliary, okay? Press enter. Here we go. Finally worked. Great. Okay, moving forward. So once we do that, now we are going to be determining which option needs to be configured to begin the DOS attack. Okay, so for that purpose, please type show space options and press enter. Space options and press enter. Here we go. So we have a list of options associated with it. So we are going to be, since we are going to be performing the sign flooding on port 21 by spoofing the IP address. So let's just do that. Okay, so let's just type the command set our host. So we are going to be telling this auxiliary tool that the remote host is the target IP address, which is 10.10.1.10. So the command for it is set space our host space 10.10.1.10. 10.10.1.10. Press enter. Great. Now we are going to be setting up the port number. So can you please try the command set space R port space 21. Space 21. Great. Good going, Kingsley. Press enter. Right. So we have done that. Now we're going to be setting the spoofable IP address. So the command is set space S host space 10.10.1.19. So what we are trying to do by setting the S host option is that we are trying to spoof the IP address to that of Windows Server 2019 because we want to be spoofing the IP address of the parent security machine with that of Windows Server 2019, okay? So once the module is configured now, we can start the attack. So you just type exploit and press enter. Type exploit, press enter. Right, so it's now sending this sign flooding to the Windows 10 machine, yeah? So now we are going to be confirming that Windows 10 machine has fallen a victim. So let's just go back to Windows 10 machine and log into that machine, please.
Okay.
Thank you. So once we log in, just let's start with the Wireshark, and it's going to tell us. Can you change the machine? For that purpose, can you please click down? Yeah, just scroll down. And not there. Can you please get out and click on the black screen outside? Okay, can you please scroll down this window? No, can you see the finish button? Can you please click under the finish button? Yeah, can you please scroll your mouse downwards? If it's not working, can you please zoom out of your window? Zoom out. Zoom out to 75. Here you go. Okay, so no, that's fine. Can you please log into the Windows 10 machine? It's number 2 machine on your left. Yeah, this one. Right, great. So once it's done, can you log into it? All right, so once you're logged in, can you please start Wireshark? Can you double click on Wireshark? Yes, here it goes. Or press enter. Okay, it works fine. Okay, once it's done, you can see the Wireshark Network Analyzer window opening right in front of you with a big capture writings on top of it. So can you please click on Ethernet? This is going to tell you if it's capturing Ethernet down bottom, yeah? So the bottom, the second bottom, Ethernet. Can you double click it?
It's so faint.
Ethernet is the number 4th option from the top. Yeah, here it goes. Double click it. So this Ethernet is going to tell you the traffic this machine is capturing. Yeah. So it's now analyzing the traffic on the Ethernet that is connected to other machines, and now it's quickly capturing all those packets that it's receiving. Yeah. So if we want to be observing the source IP address, you can see that the source IP address is that of Windows Server 2019. The source IP address is 10.10.1.19. Can you see that in the red? The red ones, yeah? Can you stop the packet analyzer now? Can you please press the red button? Here you go. Stop this. Did you press the stop button, please? All right, now can you please check one of these red ones? Can you see the source IP address is 10.10.1.19? Okay, so this implies that the IP address of the parent security machine has been spoofed. Okay. So now we would be observing the target machine, which is Windows 10, and we can see that it's slowed. It's slowed because if you would try to open anything, it would be very, very slow, okay? Because the attack is being continued. So let's go back to the parent security machine and press Control C to terminate that attack. Please press Control C, Control and C all together onto that terminal window. Can you click onto that terminal window? Inside that window. Here you go, okay? So now we have terminated the attack. So the things would be well and good back there on that system now. So this is how we demonstrated the performance of assigned flooding on the target host machine, and we used Metasploit for that purpose, okay? So let's continue.